theorem well in order to be able to do what we're going to be doing. So for Pythagorean theorem, our Pythagorean theorem is used for right triangles only. So you can only use Pythagorean theorem in a triangle that has a right angle. Pythagorean theorem does not work if the triangle does not have a right angle. So A, B, and C, it matters where those go, or at least it matters where C goes, because C is a special side. What is the name for your C? Hypotenuse. Why is it doing that weird? Okay, so C is your hypotenuse. It is the longest side. It is also across from the right angle. That symbol right there means angle. I don't know why it's putting these triangles right in the middle of everything. Okay. Alright, so C is your hypotenuse. That is a word that you need to know, hypotenuse. A and B also have a name. It's a less complicated name. Do you guys remember what it is? Anyone remember what A and B are called? Legs. Good. Okay. So A and B are the legs of the right triangle. They are your two shorter sides. They're also going to touch the right angle. Okay? So I guess we'll write that down. Shorter. And when I say touch the right angle, that means like on one end, that's where the right angle is going to be. The hypotenuse does not touch the right angle. It's across from the right angle. Okay? And so Pythagorean theorem is A squared plus B squared equals C squared. Whenever Hunter was little, like 4 or 5 years old, I would teach him formulas just so like he could impress people. And so he knew the Pythagorean theorem was A squared plus B squared equals C squared. I haven't told him that in a while. I don't know if he still knows it, because he obviously was just memorizing something he didn't know what it meant. But whenever he was in kindergarten, he was here after school one day, and he was going to write the Pythagorean theorem on the board for me. So he wrote it like this. That was his A squared plus B squared equals C squared. But of course we're raising this to the second power, not that we're drawing it inside of a square. He also knows the derivative of x squared. Or I hope he still knows it. Yes. Yeah. The derivative of x squared. Because I taught him what the derivative of x squared is. It's 2x. 2x. Mm-hmm. I'm grooming him to become a math genius, yes. I don't know if he still remembers that.
What grade is he in?
3rd.
Does he get good grades?
Pretty good. He likes math, but he likes reading also. All right. Okay. So, let's do an example. So for this one, Aiden, what are the legs of this triangle? Okay, and what is the hypotenuse? X. So we're going to put this into the Pythagorean Theorem. We'll have 5 squared plus 12 squared equals x squared. And Ian was 5 squared. Very good. Jesus, what's 12 squared? 144. And then we need to add those together, so we'll get 169 equals x squared. Okay? And you might know what the square root of 169 is. It's 13. So we'll take the square root of both sides, and we'll get 13 for our x. Okay? Alright. Okay. Questions? Okay. Let's do another one. Okay, let's see. For this one, Cole, what are the legs of this triangle? 2 and B. Tristan, what's the hypotenuse? 8. So to put this in the Pythagorean Theorem, we're going to have 2 squared plus B squared equals 8 squared. The biggest mistake I see students make is they always just use the numbers on the left-hand side. They'll say 2 squared plus 8 squared equals B squared. But 8 is the hypotenuse. It has to go over here on this side. Okay? So, Zena, what is 2 squared? And that was too easy. So what is 8 squared, Zena? 64. So we're going to solve that equation. We've got to subtract 4 from both sides. So B squared equals 60. And then for this one, we've got to square root both sides because a square root is the opposite of squaring something. They're inverse operations. So we're going to have B equals, anybody know the square root of 60? Is there a whole number that is the square root of 60? There's not. What is it going to be between? What two numbers will it be between? It'll be between 7 and 8, right? Because 64 would be 8. It's going to be fairly close to 8. I will let you use your calculators on this. Don't run and get them right now. I'm just going to use the one on the screen for right now. We'll get them in a second. So square root. To do a square root on your calculator, you'll do second and then the x squared button. 60. And so we get 7.754966692. Let me go ahead and give you my general decimal policy for this class, and this applies all semester or all next semester. My general policy, I go with the same policy that they use on the AP exam for calculus, and that is, unless I tell you different, keep at least 3 decimal places. So I'm going to round this off to 3 decimal places. If you keep more, that's fine. I don't care, but don't keep less. Okay? So unless the worksheet that you're working on tells you to round to fewer decimal places, always keep me 3 decimal places. Or the rare exception that it's something that doesn't make sense to have 3 decimal places. For example, if it is money, 2 decimal places is usually what you want to do because cents would be 2 decimal places. So unless I have told you otherwise, always keep at least 3 decimal places. So if we're keeping 3 decimal places here, we'll have 7, 7, 4, 6. Okay. Now I will accept it if you put 7.745966692. You can write the whole thing if you would like. Typically, we don't need that many decimal places. We don't need that level of accuracy. But if you keep more, that's fine. But please round correctly if you do that. So we're going to go with the 3 decimal places here. Okay, questions? All right, let's do one word problem. Let's see, hold on. A word problem. A football field. Yes, please. Feet. 66 feet. Is that accurate? I think it is. How wide is a football field? Let's give it a quick Google just to be sure. Right, we'll just talk about the play, not the actual, all the grass, because you're right. You got end zones or stuff like that. Let's see. I knew the 100 yards was correct. What's the width? I mean, that probably can vary a little bit more, but let's go. Width in NFL field. We'll go NFL. Oh, wait, no, it's way wider than that. Let me fix that. Hold on. Okay, 160 feet. Okay. All right. So, if I have a football field, like this, I want to know what is the length of the diagonal. Of the field. I'm going to make this multiple choice. I want you guys to do this one for me. Even though, go ahead and get your calculator. You'll need it on this one. I do want you to do this one for me. So run and get your calculator. Yes. The square root, if you hit the blue button and then the x squared button, it will put a parentheses with it. It depends on whether you got the newer calculators or the older calculators. Some of the newer ones, Miss Ball probably had new ones because they bought her a new set when she went down to middle school. it'll put a square root sign. The older ones, I think the older ones are like, I think this one's like the older one. Whenever you do this, it's going to do a square root with a parentheses. So like if you're doing the square root of 125, you have to close the parentheses for it, and they'll take that square root. Oh, yes. Jennifer, you need to go get your picture taken down in the media center in Lobby Biblioteca. All right, do this problem for me. All right, do this problem for me. Feet and yards are not the same. So I gave you this one to make you see how very critically important it is to pay very close attention to your units. Tristan had a very good point that he was saying. He said that C and D could not be the answers because they're not longer than 160, which would be true if you completely ignored the units. But 113 yards is longer than 160 feet. And 124.9 yards is longer than 160 feet. Okay? So, since all of our answer choices are in yards, let's change everything to yards. So I'm going to leave the 100 the same. How would I change 160 feet to yards? We're going to divide it by 3. Right? Because yards, we should have fewer yards than we do feet. Right? So we're going to divide by 3, and we get 53.3 repeating to that. Okay? So, now, and if you think about what a football field looks like, it doesn't even make sense to have this side right here be 160 if you're thinking in yards, because 106, like when you look at a football field, it is longer than it is wide. So, 53.3 repeating yards, we have to change that first, and then we can do Pythagorean Theorem. So we'll have 53.3 repeating squared plus 100 squared equals C squared. So in our calculator, to do a repeating decimal in your calculator, you can't really do it. But what you can do is just put lots and lots and lots of 3s, and it'll be close enough. Because eventually it gets to the point where your calculator can't, it just kind of recognizes that as repeating because it's going to round off to a certain amount anyway. So put lots of 3s. Don't just put 1 or 2, but put lots of 3s. Plus 100 squared is going to give us 1, 2, 8. What was that? 4.4 repeating equals C squared. Let me show you something on this calculator. That's a repeating decimal. I can type this in with that number and just put a lot of 4s. Or now I need to undo that square, so I need to square root both sides of the equation. So I can do this. Second square gives me the square root. If I just want the number from the last line, I can do second negative key, and it'll put the answer there from the last line. That way you don't have to type it in, and you won't have to round. And so C is our answer, 113.3 repeating. Okay? You said all of the letters at one point, Adam. So, alright. The closest I saw to looking at that is Bailey back there. She got B because she changed 100 to 300. So, B would be correct with one small correction. If that was feet, then it would be correct. Because Bailey was actually turning everything to feet. But she was at least thinking about the units. So she was in the right direction there. So whenever you're doing anything with length, please pay close attention to those units. Because the units matter a lot. So, for example, if you asked me how much I weighed, and I told you, hold on, let me get something realistic here. I told you I weighed 70. Would you believe me? Do I look like I weigh 70? What if I'm talking about kilograms? 70 kilograms would probably be, assuming it is about 2.5 pounds a piece, or I can't remember the exact conversion, but it would be roughly close to my weight in kilograms. But in pounds, I do not weigh 70 pounds. Right? That is a lie. I haven't weighed 70 pounds since I was in the 2nd grade. I was a big kid. But I do not weigh, I have not weighed 70 pounds in a very, very, very long time. So units are very important there. If I ask you how tall you are, you would probably tell me 5'2" or 6'1", and because that's what we normally answer with. But if you asked me how tall I was and I said 68, I'm probably talking about inches, right? I don't know the conversions in my head for meters, but those are really important. If you ask me how far it is from here to Walmart, and I tell you 10, okay? It could be miles. I could mean minutes, because I might not be answering with a distance. I might be telling you how long it takes to get there. So it's really, really important to know what your units are whenever you're answering something. Let's see. Mark and Jennifer could probably, they are not from the United States, so they do not use feet. Use meters. Let's see. What, metros. Metros y kilograms. Kilograms. You guys have learned your Spanish here and not there, right? Yeah. But they, I have had, okay. So for example, like, a very basic question I might could ask you would be how many inches are in a foot? 12. If you can't answer that, then that's a big problem. But, Mark and Jennifer might not would be able to answer that because they're not used to answering with U.S. Units. I know whenever I went to Mexico, whenever I was in college, the speed limit seemed so high. You'd go down the road and it'd say speed limit 100 kilometers per hour, not miles per hour. So I think it said kilometers per hour, maybe along the bottom. It would not get you out of getting in trouble, I'm sure. So the rest of the world doesn't really know about yards, and if they do, it's only because they've paid some attention to some American football, probably. But Americans use weird units. So it's really important to know what you're talking about whenever you're talking about those units. Because as we see with this problem, the whole entire class got it wrong. And you guys were pretty sure you were right. So sure that if any of you got B, C, or D, you are not going to raise your hand because everybody was going to laugh at you and make fun of you for not getting A, which was the right answer. Because I know it would have happened. Not everybody raised their hand. Some of you might have had the right answer out there. I didn't see anybody with it, but might have had the right answer and just didn't want to say anything because you thought you were wrong. This also proves the majority is not always right. Sometimes. So,